Hello all and welcome to Study by Technologies. I believe you already have introduction about instructor, that's about me only. So let's skip this page and let's check about the topic that we are going to discuss for today. That is parallelism over PIG. We all know that this PIG is basically a kind of a functional programming language which we use in the Hadoop environment actually. So here we all know about MapReduce as well, and we also know that the PIG program actually get converted to the corresponding MapReduce automatically get converted to the corresponding code of MapReduce as well. So one of the PIG's core claims is that it provides a language for parallel data processing. For this purpose, it requires you to tell how to parallel it should be. To do this, it provides a clause that is called as parallel. This parallel clause can be attached to any relational operator in PIG Latin. However, it controls only the reduce side. So it makes sense only for operators that force a reduce phase. These are group, order, distinct, join, limit, co-group, and cross. So now let's take one example here. Let's try to understand from a practical point of view. It's something like I have this kind of environment and I have my program. It's like in the form of a script that is program.py. I have my data in my DFS like Hadoop fs-ls user the I have my data over here and I want to let me check it out what kind of data it is. Hyphen get something like this way, and this is the data, a small data obviously I have it, and I would like to find out how many times each and every word have been repeated. As you might have idea about, like in our previous videos also you might have seen this kind of environment. Now let me open my this program.py. I'll execute this script and it will sort out the result accordingly. So before we go ahead, let me check my program. Okay, everything is fine. Just a test purpose, so I'm not going to store my output anywhere. And as I told you guys that this parallel could work with one of the keyword, that is the group over here. So let me put it as parallel. Let's take it 10. Okay. So actually, what we are trying to do here is like we are checking for the number of reducers, parallel reducers here. Okay. Just go ahead and escape it. Colon WQ. Okay. Now if I execute the script, it will something like pig program.pig. Let it get executed. Okay, you can see the Java file has been created here, and let it go on. See here that job got 50% over, and 55, then 60. It is actually, we have 10 different, parallelism we have set actually, choosing all these reducers like this way. We'll also see, like, if we can make default, that is without any parallelism, what happens. We'll also see that. So you can see here, since we have deployed 10 different reducers over here, so it's showing you the way of parallelism. And this is your result. Now if we check out what happens if we do not use the parallelism over there, let me edit my program once again. This time I'm going to remove this clause parallel to be 10. Okay, and let me execute this script once again. You can see here that MapReduce job has been completed by 50%, and soon it will complete the full task accordingly. And yes, you can see here, so that's how it is done. Now, this example, this parallel will cause the MapReduce job spawned by the PIG to have 10 reducers. Okay, and this parallel clause apply only to the statement to which they are attached. They do not carry throughout the script. And the above script, if you can check it, we have attached this parallel, sorry, we have attached this parallel over here, right? So it will be affected only on this particular line of code. It will not get carried over to this line. So it's something like, if let's say, take an example, like say if this group is actually followed by some order by clause or something like that, and later on you can change the parallelism over here. Let's make it 2 or something like that, right? That's completely based on your requirement. Now, if, however, you do not want to set the parallel separately for every reduce invoking operator in your script, you can set a script-wide value using the set command. Let me remove this. Let's say, as you can see here, I was trying to put parallel in all the lines like this, but I do not want it to be repeated again and again. So what I'm going to do is, like, I'm going to use it set default underscore parallel to be, let's take it 10. Okay, you can take any number based on the requirement. Now it will check for all these rows for this particular parallel value. Like, come out of this file, and now if I execute this particular file once again, it will get parallelized based on the default value of your parallel. That's what we have set at the beginning of the code. You can see here that it's 50% done, and now the same way it will work for 55, 60, 65, and so on till it reaches the 100%. So here also the MapReduce jobs will be done with 10 different reducers. Now remember that the default value of parallelism in MapReduce is 1. And this parallel only lets you set the reduce parallelism. Now what about the map parallelism? This MapReduce only allows users to set the reduce parallelism. Okay, you can see here that total input paths for this process is 10, right? So this it controls the map parallelism itself, and because PIG cannot control map parallelism, it cannot be exposed that to its users. Now finally, what happens if you do not specify a parallel level? So under the PIG, before the version 0.8, it lets MapReduce set the parallelism, right? This MapReduce default parallelism is controlled by your cluster configuration, and the installation default value is 1, and most people do not change that. This simply means you will run only one reducer, which is rarely what is required. So in order to avoid this, parallelism clause is added, and it looks at the input size, assumes that there will be no data size changes, and then allocates a reducer for every 1G of data. We must remember that it is not a good algorithm. It is provided only to prevent mistakes that result in a script running very slowly, and in some extreme cases, mistakes that can cause MapReduce itself to have problems. Remember that this is basically a safety net, not an optimizer. So guys, that's all for PIG parallelism. Let's come back to our PPT and let me make it confirm. If you need some more details on this, for training requirements, you can visit our website studybay.net, and you can mail us at hr@studybay.in, or you can call us at 700-70-34421. You can order our book as well from pothi.com with a mentioned node number, that is 188662. Thank you so much. Please share, like, and subscribe this video. Bye bye and have a nice day.